Good morning students. I am your new science teacher Akriti. I will teach you chapter 3 of class 9, atoms and molecules. To start with the chapter atoms and molecules, we have to go back in our previous classes as we studied about matter. So matter is anything that occupies space and has weight is called matter. So I will give you example, that is a pen. It is placed on my hand. It occupies space and it has weight. So that's why this pen is called matter. So when matter is finely divided, whose further division is not possible, we get a particle. So Maharishi Kannad described that particle as Parmanu. So Parmanu is the part of matter. It is a particle that is derived from the matter whose further division is not possible. So he called that particle Parmanu. But nowadays that similar particle is called atom. So what is atom? Atom is a particle, smallest particle or indivisible particle of matter whose further division is not possible or which can take part in a chemical reaction. So from these chemical reactions we get a number of compounds. So to verify these compounds we have some laws. These laws are called law of chemical combination. That is how atoms combine. So the laws which govern the combination of atoms is called laws of chemical combination. We have two laws of chemical combination. That is number one, law of conservation of mass, and number two, the law of constant proportion. So firstly, law of conservation of mass. The law of conservation of mass states that mass can neither be created nor be destroyed. What does it mean? If I have considered a chemical reaction, that is A plus B gives C plus D, the mass of reactant A and the mass of reactant B, the sum of mass of A and mass of B is equal to the sum of mass of C and mass of D. So you have an activity in your book. Please open your book and see the activity that is on page number 31, that is starting of your chapter. Look at this activity. What does it state? It states, if it takes a conical flask having a reactant B and a small fusel tube or ignition tube having a reactant A, place this tube in a conical flask and mix the content. Firstly, you have to weigh the content of A as well as content of B. When you will mix these two reactants, you will get a product whose mass is equal to the sum of the mass of reactant A and B. This reaction governs the law of conservation of mass. Law of constant proportion. It states that in a chemical substance, the elements are always present in a constant ratio by mass. What does it mean? It means 18 gram of hydrogen is formed from 2 gram of hydrogen and 16 gram of oxygen. If you see the ratio of 2 into 16 in a simple whole number, that is 1:8. If you take a water of your home or from the river, the composition of hydrogen and oxygen is always 1:8. So the law of constant proportion states in a chemical substance, the ratio of the elements always in simple whole number. So that is your law of constant proportion. So the next topic is Dalton atomic theory. This atomic theory explains about the nature of the atoms. The Dalton atomic theory states that a matter consists of a smallest indivisible particle, that is atom, as I already told you. It gives a few features of atom because the name indicates the Dalton atomic theory. So, the Dalton atomic theory gives the first postulate. Number one, a matter composed of atom which is indivisible. Number two, atom can neither be created nor be destroyed. Number three, the atoms of given elements are identical in physical as well as chemical properties. Next, the atoms of different elements have different physical and chemical properties. Next, the atoms combine to form a molecules and compound in a simple ratio, as this postulate is given by the law of constant proportion. Next, atoms of same element or a compound have number of atoms and kind of atoms always constant. That is, the H2O always contain hydrogen and oxygen. So these are the postulates of Dalton atomic theory. The postulate number 2 is given by the law of conservation of mass. The next last is the atoms combined in small ratio is governed by the law of constant proportion. So these are the postulates of Dalton atomic theory. These are the main postulates. Now the next is atoms. You can see the symbols I have wrote on these examples. Firstly, you have to open your books and see the page number 34 and table number 3.1. These are the symbols of the some elements you have to learn by heart. It will be helpful in my next lecture. Please learn these symbols by heart. I will discuss about them in next lecture. So firstly, the atom I will explain earlier is the smallest particle which can take part in a chemical reaction. So the IUPAC, that is International Union of Pure and Applied Chemistry, gave the symbol to particular element. So this IUPAC is approved that names of the element and the symbols of the element. It is approved by this IUPAC. In earlier you have seen these symbols are look like that, but these are the ancient time when these symbols are used. But now the symbols are used by us is given by IUPAC. So you have to learn this. The next is atomic mass unit. So the atomic mass unit is AMU, or nowadays it is given by U, that is unified mass. So what is unified mass? The atomic mass unit is the mass unit, that is the mass of atom, that is 1/12 mass of the carbon atom. What is that? Atomic mass unit is the mass unit of an atom is equals to the 1/12 mass of the carbon atom. Here the carbon 12, that is mass of carbon atom, is referred as standard reference to calculate the mass of the other atoms. Next is relative atomic mass. As the relative atomic mass name, it is the average atomic mass of an atom as compared to the mass of C12, that is 1/12 mass of the carbon atom. So that is relative atomic mass. So for this you have to see the table number 3.2 on page number 35. These are the elements and these are the atomic masses of the element. You have to learn these masses of the element by heart. So what's your homework is you have to learn the symbols of the element and the masses, atomic masses of the element. So next topic is molecule. Molecule is the smallest particle of the element or compound. Next, molecules can be monatomic or diatomic. So molecules is the combination of two identical elements or two different elements. So first is molecules by element. So molecules by element is the combination of two elements, that is H plus H, that is H2, O plus O, that is O2. So these are the molecules. They can be monatomic, diatomic. What is monatomic and diatomic? Mono means one, atomic, that is atom. Diatomic, di means two, atomic means atoms. So that is H2. H2 is molecule. It contains two atoms. That is why it is diatomic molecule. He, that is helium. So it contains only one atom. That is why it is monatomic. So next is atomicity. Atomicity means the number of atoms that can combine. The number of identical atoms that can combine. So it is of these type: monatomic, diatomic, triatomic, tetratomic, octatomic. What does it mean? Octatomic. As the name, octatomic means S8. S can combine with 8 sulfur atoms. Tetratomic, that is P4. It can combine with 4 phosphorus atoms. So P can combine with 4 other atoms. Triatomic O3, that is oxygen ozone. So when it combines with 3 oxygen combines together, it called ozone. So similarly, diatomic O2, oxygen, H2, hydrogen molecule, Cl2, chlorine molecule, and 2, diatomic nitrogen, that is molecule. Whereas iron, helium, sodium, aluminium, argon neither combine with any one of same type of atom. So that's why they have one atom. They can neither combine with itself. So that's why they are monatomic. So you can learn the symbols from your book. Then you have to learn their atomicities. So next is molecules of compound. So molecules of compound means when two different elements combine together, it forms molecules of compound. Earlier I told you the molecules of elements. That is when two same elements combine together. These are the molecules of elements. For example, in water, that is H2O, having two elements which are different, hydrogen and oxygen. In ammonia, NH3, you have two elements, that is nitrogen, hydrogen. In carbon dioxide, you have two elements, that is carbon and oxygen. So, in this lecture, I told you about atoms, molecules. So, you have to firstly learn the symbol of elements. And after that, you have to learn the mass of the elements, which will helpful for the next chapter. So, it will be helpful for you.